Alright, welcome to Chapter 3, Part 1. So in this Part 1, we're going to talk about flavor generation in meat. Alright. Okay. Alright, why do we use a cooked meat as an example? Okay. The reason, right, why we are using cooked meat as an example in Part 1 is because the flavor generation in cooked meat illustrate most of the key aspect of flavor development in cooked food. Okay, so most of the cooked food, right, is sort of like is a very good example. Okay, because it cover a lot of the different the key reactions here. We present fundamental reaction occur in cooked and store food. Yeah, the fundamental reactions we are talking about here, right, including like Maillard reactions, Strecker degradations, okay, the lipid oxidations, okay, caramelizations, and so forth. Yeah, important aroma compound generated during cooking or fermentations. All this aroma as the flavors, as the time given more, the reactions time given more, usually we generate a lot of all this aroma. Yeah. Very simple. If we're looking at comparing between the raw meat and cooked meat, raw meat is bland. Okay, I'm not sure whether you have tasted raw meat before or not. For example, maybe sashimi. Sashimi is a good example that you can eat raw. Okay. Usually there's not much flavor. Okay, very bland, and of course there are some flavors, but not very strong. But as soon as you cook it, what happens is that during the process of cooking it, okay, of course subjected to what kind of the cooking conditions that we're going to talk about later on, over 1,000 aroma compounds have been reported in cooked meats. That is when it generates the flavors for eating, yeah, for enjoyment. Before we talk about the flavors in the cooked meat, of course, you need to look all the way to the first part here. Before the animal has been slaughtered, conversion from muscle to meat to cooking. Okay, so these three parts, it all has to depend on this part as well. Okay, the species, the sex, the age of the animals, what it has eaten, and also the conditions and just prior to slaughters. All these can affect how the flavors generated, okay, during cooking. Okay, not only cooking, of course, you got aging, storage, all this can be affected by these conditions. Okay, let's look at more closely here. The diet, very, very important. The diet actually affects the composition of the meat. For example, like this chicken over here, you can see is very yellowish. Okay, the reason why it's very yellowish is because it's corn-fed chicken. Okay, and the yellow come from the corn, and you can see that is very yellowish. Of course, if you cook this, the flavor will be slightly different because of certain components are in the meat itself. Okay, then of course the species is different. If you're talking about chicken and talking about lamb, okay, the type of the aroma is different. Okay, you can see that the lamb is slightly more strong in the smell compared to chicken. Alright, the sex as well has a big difference as well. The sex between male and female. Male have and female, they have different hormones. Of course, these difference in hormones can also result in a different type of taste. Okay, the age, you can see from here, comparing lamb and mutton. Okay, these two, lamb is when the meat was from a sheep younger than 1 year old. Mutton is from the meat from sheep that is 1 to 3 years old. Okay, when they grow older, of course, the mutton, the flavor will be stronger, a lot stronger compared to lamb. Okay, some people, they do not like the strong flavor, they can go for lamb. Alright, is conditions at or just prior to slaughter, these can affect the conversion from muscle to meat that we have discussed previously in Culinary 101. Okay, is condition at just prior to slaughters, it got one of the thing is that it got to do with the glucose level, okay, the amount of glucose level in the myoglobin, okay, in the muscle cells, as well as the accumulated lactic acid in there, okay. So this can affect the conversion from muscle to meat and can result the PSE normal DFD meat, yeah. Okay, of course, if you are cooking these meats, okay, the flavor generated will be different, okay. This one is higher pH, okay, less exudate, okay, and this one is lower pH, okay, and a lot exudate, yeah. So you can see from here the composition will be different as well. This one more or less it has been drained, okay, the nutrient has been drained out, okay. This one is a lot in there, this one is somewhere in the middle, okay. So all these can affect the taste, okay, the flavors after you cooking, yeah. So it's very important that not just the cooking itself, make sure that you choose the ingredient, okay, which is the meat. The quality need to be good in order to generate a good quality the flavor. Okay, let's talking about the cooking methods. Okay, cooking methods. We got different types of cooking methods. Cooking methods. Okay, meat is cooked using different methods. Okay, we got dry heat methods. For example, like shirring. Okay, then oven roasting, grilling. Okay, microwave ovens. Okay, all these are dry heat methods. Okay, actually microwave is not really dry heat. Okay. Okay, microwave is by itself, or you got the wet type of moist type of the cooking methods here. The choice of cooking methods depend on the type of meat, okay, the amount of connective tissues, and the shape and size of the meat. For example, if you are talking about the whole chicken, for example, you wouldn't like go and pan fry the whole chicken, okay, you will grill it, allowing the heat to go inside. Okay, that's why it's got to do with the size, okay, the shape as well. The type of meat as well. Some of the meat, they are better in grilling compared to boiling, for example. Okay, so all these are different type of cooking methods, and depending on the type of meat, the amount of connective tissue in there, the shape and the size of meat here. For example, if there are a lot of connective tissue, okay, usually you go for slow cooking, yeah, stew, okay, stew or slow stew, okay, like stew, don't be boiling, okay, stewing. Then they can reduce, okay, can soften the connective tissue, okay. So the different cooking methods of meats, we got dry heat cooking. Dry heat cooking, we got grilling, broiling, okay, barbecuing, roasting, baking, sauteing, pan frying, deep frying. Moist heat cooking, we got steaming, poaching, simmering, boiling. Okay, sometimes you can have combination of that, like stewing or braising. Okay, so you can see from here, it's very obvious that if you're using the dry heat cooking compared to the moist heat, you can see that the color of the surface of the meat is different. Okay, and you can see the stew as well, that can help to loosen, okay, or soften the connective tissues. Okay, so different methods actually use it for different type of the dishes as well. Of course, it depending on what are the meat you are trying to use. Some of the three main factors here, the different cooking techniques, is the temperature at the surface of the meat, okay, whether you want to have high heat at the surface or not, then temperature that is penetrating into the meat, okay, through the meat, okay, and also depending on the method of heat transfer, you can have contact, okay, direct contact, okay, or maybe through air, okay, and steam, or microwave. Microwave is very special because it actually cooks through vibrating the water molecule, yeah. So the region with the highest water moisture content usually will heat up first compared to other regions, okay, and usually they will cook from inside out, yeah, for microwave. By looking at this as well, you can see even though it's oven, the conventional oven that doesn't use fan will go through the radiant, whereas the convection iron, they will have the airflow that actually pushes the heat throughout the oven and onto the meats here. Okay, later I will show you some examples as well. So dry heat cooking and moist heat cooking, what's the difference in the cooking conditions? You can see dry heat cookings usually the temperature is a lot higher, about 150 degrees Celsius to 160 degrees Celsius. Okay, the moist heat maximum is 100 degrees Celsius, because more than 100 degrees, if you boil off, okay, the water will evaporated. Unless you're using like pressure cooker, then perhaps you can go slightly higher temperature. Yeah. So the when you're talking about the high temperature, especially the high temperature, then what happens is that the precursor, aroma precursors that is in the precursor, later we'll see, precursor is all the compounds, okay, or molecules in the meat that actually subject to heating that can create further flavors, right? Whereas these 100 degrees Celsius, it won't say that there's no reactions, okay. The precursor will still react, but at a slower and at a lower degree of reactions. Yeah. Okay, when you're looking at this, okay, hold on. Okay, when you're looking at this dry heat cooking process, okay, of the transfer in the oven, you can see from here that when you started, okay, this one is a convection ovens here, okay. The core temperature will start to increase, okay. So of course the temperature, right, will start to if it's just the normal conventional ovens, then you go to the radiant, okay, the radiant that go to the meat. But with the convection, then will facilitated by the air driven onto the meats. And once the heat going through, what happens is that the heat will penetrate into the meat as well, and the core temperature will start to increase from 0 to 85 degrees Celsius. When the heat increases, the protein will start to coagulate, okay, and then the browning will start to begin. Of course, it depending on the concentration of sugars in there, okay. They will have a certain, okay, so there are certain degree of the sugar in there, yeah, all the meats they have, okay. Later we will talk more about this later on, yeah, talking about the precursor in the meat. Then, of course, the water will start to lose, okay, as the heat evaporates, okay, the water, and the fat will start to melt, okay. Of course, the fat, once the temperature reaches the melting temperature of fat, it will melt, and the cell will rupture as well. Then the fat will leak out, and then it's available for chemical reactions like degradation, okay, lipid degradations. And of course, all the after that, they will have the reaction will proceed more and more, and there will be a change in texture and the flavor, okay. Mainly the texture is as well is because of the degradation and the heat as well, denaturation, yeah. And the flavors, okay, more or less is the generation from the reactions, okay, caused by heat. So you can see from here, again, these two figures here, it's very interesting that you can see if you are heating at lower temperature, about 100 degrees Celsius, you can see that the surface is lower temperature, okay, the core is 60 degrees. But if you are heating at the same higher temperature, a lot higher, 160s, okay, you can see that the surface is a lot the higher temperature, yeah, 95. The core is still 60, yeah, because of the penetration depth, okay. So if you look at that, you are cooking at the higher temperature, what happens is yes, browning, and the core may not be fully cooked, yeah. So it's really depending. That's why sometimes, right, even though you fried chicken, okay, it's very high heat, but inside is still raw, okay. That's one of the reason, yeah, because they need time to cook into it. Alright, so if you want to have more even, then you need to play with the temperature to allow inside to be the core temperature to cook, as well as the even browning or cook at the surface. Okay, so that one you need to adjust the temperature. Okay, next. Alright, let's talk about the dry heat cooking here. Dry heat cooking, you can see that is the water activity is very low, okay, because it's dry heat. Okay, when the water value is very low, okay, activity is low, combination with a high temperature and dry surface, okay, that these conditions, right, will allow increased production of flavor components here, okay, which give the roasted the odors, notes, and flavors. Alright, so there will be more volatile compounds produced with increased cooking temperature. Okay, some of the reactions that favor by this kind of the conditions, okay, is like the Maillard reactions, okay, which is the reaction between the reducing sugars. All these are already in the meat itself, reducing sugars like glucose, fructose, and those amino acids. Okay, amino acids is like for the muscle, there are plenty of it. The proteins, they have amino acids in there, so they can freely react with the reducing sugars. Alright, to and then undergo Maillard reactions. Okay, as the Maillard reaction proceeds, more and more flavors will be produced. Yeah, I'm going to talk more about this in the following sections. Yeah, then the sugar will melt and decompose. Okay, which lead to caramelization. Okay, then the fats as well will degrade. The fatty acids that degrades, right, normally is from the if you're talking about like lean meat like that, it's going to be more or less from the cell membrane. Okay, the cell membrane which contains the lipid bilayer. The lipid bilayer, the fats will degrade and create those volatile flavor compounds here. Not the adipose tissue. Adipose tissue, they have a different type of the flavor as well. Okay, but most likely, like for example the chicken breast, the fats is from the of course from the skin. Okay, and from the cell membrane of the muscle tissue. Yeah, moist, you can see that the temperature is not a lot higher. Okay, when it's not a lot higher, is because the water will evaporate at more than 100 degrees Celsius, so the temperature wouldn't go higher than that. Okay, but it's good to soften the collagens. Okay, because it's a slow even denaturation, and I can cook at a longer time as well. Okay, the vat, because it's very high water activity of Maillard reaction can't happen. Lipid degradation can take place at lower temperature, so some I wouldn't say a lot compared to the dry heating. They still have a certain level, okay, of the flavor generated from lipid degradations. No caramelizations. Okay, that's why it's white color. You can see from here. Except if you are using pressure cooking, yeah, then the temperature, if go higher than 100 degrees Celsius, then more of the flavor components can be generated. Yeah, possible Maillard, possible caramelizations. Okay. All right. The low heating yields homogeneous appearance but less tasting layer or doneness, so you can see from here. Okay, can see very appealing actually compared to these two. Yeah. Alright, let's go through one by one of the reactions from the cooking process. We have just I mentioned the lipid oxidation degradations, then we got Maillard reactions, then they got sugar degradations and caramelizations. Lipid oxidation and degradations, as I mentioned, okay, if you're talking about the adipose tissues, okay, they have the oxidation possible as well. But if you are talking about lean meat, okay, it's more towards the lipid bilayer, okay, or the cell membrane, and it does contain some unsaturated fats as well at the lipid bilayers. The autotoxidation is possible as well, but the degradations, oxidation and degradations, it wouldn't be create what we call the rancidity, undesirable flavor or rancidity, because the cooking is only a short term, okay, not very long. You say maximum like maybe 30 minutes to 1 hour or so forth. Okay, if you want to have a rancidity, you're talking about days of oxidations or months, days to months of oxidations. Then you can create this. if you're talking about the short-term cooking, okay, heating, more or less you can create those cooked meat flavors, okay, 100 of those volatile compounds in the cooked meat flavors, like all these here, aliphatic hydrocarbons, aldehydes, ketones, alcohol, carboxylic acid, and so forth. Yeah, this one later I will look at later on the end of the part 1. Okay, then you can see how all these components give what kind of the flavor. Okay, if you want to have more information on this as well, okay, you can look at the handout 2. Yeah, okay, handout 2. Second is the Maillard reactions. Okay, Maillard reactions it needs to start with the condensation reactions. Okay, the reaction between the reducing sugars and the free amino groups of the amino acids here. So these free amino acids, the free amino group of the amino acids can be originated from the muscle proteins. Okay, the actin and myosin. Okay, it can be originated from there. Alright, and to form what we call the N-substitute glucosamine. Yeah. Then after that, you will undergo the Amolduri rearrangement to form this 1-amino 1-deoxy 2-ketosis. These two, step 1, step A, step B. Okay, the compounds resulted. There's no flavor. Okay, there's no flavor. There's no taste, no flavor. The flavor only generated when they start to come with the step C, dehydration, and the which resulted in reductants and dehydroreductants. Okay, that's where the flavor start to come. As you allow the Maillard reaction to proceed further, okay, giving more time to proceed, then you start to produce the fission products, which is the further split of the molecules. Okay, when it split, what happens is you get more flavor compounds. Okay, when you create some of the dicarbonyl compounds, okay, then it can undergo the structural degradation. Okay, is where the dicarbonyl will react with the amino acids to form all these different type of aldehydes, flavors aldehydes. Then step F is that then they will degrade more, okay, to give aldose and high molecular weight nitrogen-free polymers. Yeah, this is almost too late already. Yeah, because what happens is that when you form all these high molecular weights, then it's time for them to form what we call the brown nitrogen polymers. It's called melanoidin. That is the brown pigment. Okay, when you see brown pigments from your from the bread or from the meat, okay, that's a generation of melanoidin. Certain degree of melanoidin is okay. Okay, it can give an indication that it already proceed to here. Okay, but if it's too much melanoidin, what happens, right, is that the melanoidin itself, okay, even though the color, but the taste is bitter and burn smell. Okay, so you wouldn't like go too much until here. Okay, you will allow a certain degree of here. Okay, then you stop. Okay, if you let them proceed more and more, and you see a lot of the brown melanoidin form, then you taste that there's some burn smell. Okay, the burn and bitter taste. Okay, burn smell and bitter taste. So that's why when talking about the cooking, usually they will have a set amount of the cooking time. It won't like for too long. Okay. For the Maillard reactions, okay, it really depending on the water activity, the pH, okay, which facilitate the Maillard reactions. Yeah. Okay, water activity of course is low. Okay, the pH usually slightly higher pH can facilitate the Maillard reactions. Yeah, okay, because of the opening of the simple sugar for reactions. Okay, we have spoken that in the organic chemistry. And the temperature, of course, higher temperature will facilitate the Maillard reactions. Okay. Alright, so these are some of the compounds from the Maillard reaction. You can see that paraxylene, you give these cooked, roasted, toasted, baked cereal type of flavors. Then alkylpyrazine give you nutty, roasted, and so forth. Okay, you can see there are a lot of the different reactions, ingredients here. So again, whether you want to create what kind of the it's difficult for you to control what is the resultant, but what you can control is the reaction timing. Okay, for example, the short heating time compared to medium, compared to the long heating times, you can see that more and more components are being generated. Okay, if you say that I want it to be so strong, okay, and I find that in this timing it gives just nice the pleasant flavors, then you just stop from there. You don't proceed further. Okay. Striker degradation is when there's a dicarbonyl compounds that is created. Okay, either can be from lipid oxidation, from Maillard reactions. These dicarbonyls, right, can react with more with amino acids. Okay, the amino acid, as I mentioned, there are abundance in the meats. Okay, because it's made of proteins. Then it can lead to creation of aldehydes. What happens next, right, is that it can further degrade and release what we call the carbon dioxide and hydrogen sulfate. Okay, these compounds, what happens is that it can produce a wide range of sulfur compounds that give the meaty flavor. Okay, when you have this cycle degradation, usually it gives those meat flavor. Yeah, of course it needs to have a proper type of amino acids. Usually meat itself, it will contains a lot of cysteine. Okay, because of the cysteine in meat is quite often, yeah, quite a lot of cysteine in the meat. Okay, so of course it depends on the composition of the protein as well. Okay, in the meat. Okay, if you're talking about some others like beet or liver, maybe not too much of cysteine, then there won't be too much of the meaty flavor. Okay, so it will depending on what type of proteins is in your ingredient. Okay. Caramelization is when the high temperature, the degradation of the sugar, okay, at high temperature. Alright, then you can see there are a lot of components, flavor components created from the degradation of the fructose and glucose. Okay, what we call caramelizations. There's a side of it is when they can generate what we call the HMF. Yeah, HMF is the byproduct from the not byproduct, it's one of the side products from the reactions. Okay, if you let them go caramelize long enough, they will produce HMF. Yeah, then HMF will produce further flavors from it. HMF, right, is widely used to check the honey. Okay, whether is it being heated or whether it has been stored for a long term. Yeah. Okay, let's look at that. Okay, so all these reactions that we have mentioned before, okay, the Maillard reactions, the oxidations, okay, caramelizations, recapitulations, all it has to be reacted from something, okay, which is what we call the precursors. Okay, the flavor precursors can be originated in the meat, or you can actually add it onto the meat. Okay, like some of the other additional ingredients that you put on the meat. Okay, which means that you actually add more precursors into the meat to generate more flavors. Okay, so precursors that we have seen in the meat, like it can originate in the meat or added to the meat, like free amino acids. Okay, free amino acids, their abundance, cysteine, all these are the free amino acids available in the proteins. Reducing sugars, okay, depending on what kind of the animals inside, okay, they will have certain level of that. Okay, of course, if you have fats, okay, vitamins, the nucleotides, okay, all these are the DNA, again, the cells. All these are the precursors that are in the meat, okay, that can further react, which means that all these can react through the Maillard reactions, caramelizations, okay, can react through lipid degradations, then can react through striker degradation to create more flavors during cooking. Okay, so the precursors, okay, the flavor precursors, they can undergo all these lipid oxidation to form the initial reactions. The components that generated from here can undergo secondary reactions to form more flavors. Okay. So these are some of the examples that I have mentioned before. Okay, aldehydes, you can see all the aldehyde can link to certain type of the flavors, like for example propanol, okay, cooked potato or meaty taste, okay, butanol, smoky fish. So certain different degree of this component in there will give you different degree of the flavors detected when you consuming your food. Okay. That's why all this, how you want to control, of course you can control through the added ingredients. You can add ingredients to your meat, and then after that you can control the temperature, control the water activity, then you control the length of the cooking timing. Okay, all this can generate different type of the flavors components. Okay, so ketones, you can see there are a lot of components. Like here, this one give you the roasted almond sweet taste and so forth. Okay, then you got from the flavors. Okay, and you got like alcohols. Okay, give you different type of the flavors and so forth. Okay, all these flavors you do not need to like remember. Okay, just need to know that how these aldehydes can link it. All these aldehyde, ketones, hydrocarbons, and alcohols can actually give you the different type of aroma or taste. Okay. Okay. There will be activity. Okay. Oops. Okay, for the chapter 3 part 1. Okay. Since baking, okay, baking of course is not meat. Okay, baking of bread, okay, will also lead to Maillard reactions. Okay, so please look at the handout 1. Okay, please read the handout 1. Okay, if you will generate Maillard reactions as well and release desirable flavors. Okay, similar to roasting of meats. Please read handout 1. Okay, bread character and antioxidant activity of Maillard reaction product of white pan bread containing various sugars by this author, okay, Shen Y et al. Okay, and after reading it, I want you to answer in the palette. Okay, if you got no question, you can say no question, and then you can answer these products. Okay, say yes, you got question, and after that you also can answer from there. Okay, please make sure in the palette you write your name and your student ID. Okay, for attendance taking. Yeah. And please remember, do not try to finish by Friday. Yeah, by Friday. So after reading it, you check it. I guess you should be able to answer all this very easy. All this available in the answer in the article itself. Okay, what are the flavors precursor responsible for Maillard reactions? Okay, what condition favor Maillard reaction during baking? Okay, and other than flavor generation, the Maillard reaction actually produce something, okay, that creates fear. Okay, what does it mean by that? Okay, what does it mean by creating a compound that can give antioxidant activity? Okay, so Maillard reaction actually is quite good. Yeah, it not only generate flavors, can also create compounds with antioxidant activity. Okay, please explain to me. Yeah, okay, what is it used for? All right. Okay, so I will stop here. Okay, please remember by Friday. Okay, please take notes. Okay, finish reading this, and also answer this, and also indicate all this in the palette. Okay, all right. Thank you.